So today we are going to look at lecture number 7 in unit number 1, right? So this is arithmetic operations. The next one is arithmetic operations. So is my voice is clear?
Yes, sir.
Yeah, fine.
Yes, sir.
Okay. So far we have seen that the number systems, and we know that how do we convert from one number system to another number system clearly. Okay, that is what we have seen for the last few classes. Now, once we have a number in your hand, we have to manipulate that number, or we want to perform some kind of operation on that number, right? For example, so what do you mean by an operations normally we perform? What exactly meaning of arithmetic operations, in fact? Which means that simply addition is the one thing, is an operation, addition, subtraction, multiplication, next division also. So these are the different operations that we normally consider as arithmetic operations. So if you perform the arithmetic operations on a binary number system, then it is called binary arithmetics. Clear? If you perform these operations on binary number system, then it is called binary arithmetics. Whereas if you use some decimal number system or any other number system, generally we can call it as integer arithmetics. What we can call it as integer arithmetics. We are not going to talk about more detail about it, more about the floating point arithmetics, but we restricted ourselves to integer arithmetics only. Okay, so therefore binary arithmetics, which means that we perform operations on binary numbers. Is it clear to all of you? So the next one is called integer arithmetics. Which means that perform operations on any radix. As simple as that. Okay, so we see that the integer arithmetics first of all. Later we go for the binary arithmetics. Okay, simple arithmetics or number system, binary number system. Any radix system. Okay, for example, you consider decimal number system. Because it's very familiar to us. So simply let us perform addition operation. For example, 7, 3, 2. Okay, 1, 3, 1. I want to perform an addition operation here. What I can do that? What I will do is that first 2 and 2 plus 1, we have to bit by bit, the digit by digit we have to add, right? So first we have to start from, this is the LSB, the lowest position, this is the highest position, right? From lowest position to the highest position, we have to go everywhere, we know that. So 2 plus 1 is 3. The answer is 3 here. So 3 plus 3 is 6, we know that. 7 plus 1, 8, we know that. So this is what the arithmetic operation that we can perform on decimal number system, right? So we don't find any problem. Let us consider here 3, 2, 6, 4, 7, 7. So how do we perform this operation then? 6 plus 7, what is the value? 6 plus 13, right? It's a 13. So is this 13? We are calling as 13. It's called 13. But generally, what is is it a valid, is it a valid digit in decimal number system? No, it's not a valid digit. Actually, when we add two digits, single digits, digit means a single one. If you add two digits, we should have a only single digit only we have to get. But here two digits has come. So what we need to call this is, instead of saying the 13, generally we need to call it as 1, 3. So two digits are there here. So this is called 1, 3. This is how we have to call. We have to say or we have to call. So therefore, what we have to see is that we keep this LSB position value as it is, like 3. So we have to send this 1 to the uppermost position. Okay, so that means that when we add 6 and 7, we'll have 13 is the answer, or 1, 3 is the answer. In this one, the LSB position, that means the least position, we can call it as the sum value, and this is called carry. This is called carry value, right? So whenever we do some kind of mathematics between some kind of addition between the two digits, okay, and the result is also a single digit, but sometimes it is not possible. We'll have two digits also possible. In that sense, what we have to do, the least position we can call it as a sum, and most position we can call it as carry. So what we have to do in order to perform the operation, we have to send this carry to the preceding stages. So that means towards the higher side that we have to place, right? So therefore, this is called 3 now, and we have to add all these things to 7 to 1. What we'll get then? 1 to 7. If you add all these things, what we'll have? Again, here is the two digit thing is there. Here this is called sum. Here this is called carry. So we have to keep the sum here. Sum is 0. What is the carry? Carry, we have to put it here. So now what do we have to do? What we have to do? 1, 3, 4. Now we have to add. What is this value? It's 8. It's a single digit only. It's a valid one. So we have to say it is 8. So therefore, what is the result of this one? This is what the result of this. So by the by, this entire thing we can call it as, this entire thing we can call it as result. It is called result. What is the results consisting of? It consisting of some value. It consisting of carry value also. Is it clear? Fine. So this is how the value for the 3 to 6 is added with 477. Okay. Fine. For the binary number system, decimal number system, we don't find any problem because we are familiar with this one, and we are always making some kind of calculations based on the decimal number system. We don't find any problem in this one. Even the first one is larger, the second one is smaller. Okay, the next one is what I have taken. It's a larger. It is a smaller one. Okay, so here I have taken a smaller one, and this is a larger one. So I don't find any problem. So far, so good. Okay, what happens if other number system if we consider? Again, one more example that we do it so that we'll have some clear-cut idea. For example, 732,639. What is the value of this one? So therefore, here 11 is the answer. 11 means 1 is there, so 1 will put it there. This is actually 7. So 7 and 6 and 13. So 13. So we have no possible to say that what is the carry is outside. So we have to keep it like this only. So here what we can say that this is the result. This is the result. The total result. In this one, if somebody asks you what is the carry information, the sum information, this is the one. 371 is the sum information. Okay, and 1 will be the carry information. Last one is the carry information. That's what we have to say. So these terminologies are most preferably applicable for the binary number system, but here that is not that much important for us. Okay, so let us take another number system, for example, octal number. So for example, 364,732. So consider this is an octal number. This is also an octal number. So what is the result of this one? That's the question. So therefore, example number two. Example number two, I'm considering octal number system. Octal. So the earlier we have seen the decimal number system. Okay, number two is that octal number system. What we do? Okay. So if you add 4 and 2, what is the octal number? What is the octal number? 4 and 2? 6 only. 6 is a valid digit in octal. Yes, I can place directly 6 here. I can place directly 6 here. We don't have any problem. When 6 and 3, so the first 6 of 8 be radix and 3 of 8 radix. What we'll get here? What is the value? But in general, in decimal point of view, what is this value? 9. Is it a 9 is a valid in this 8 number system? Not. It is not a valid system, valid number. So then how do we do this one? That means we have to convert this 9 into octal number system. 9, what is, how do we do this one? 8. 8 ones are 8. Therefore, 1 will be there. So 8 ones are 8 zeros 0, 1 will be there. So what is this value? It is the 11 base 8. So this is the right answer. If you add 6 and 3, we will find 1 1 in octal number system. It's not 9. Please remember. Therefore, what is the value? Then I can write it here. You put it least position here and transfer this 1 to next position here. Is it clear to all of you what I'm doing? Okay. Now, what do we have to do it again? So we have to add again 1, 3, 7. So all are octals only. This is octal number, this is octal number, this is also an octal number. If you add in binary, just decimal, what will be the value? It is 11, as we know that. Okay, so it is 11 in base 10 we'll have. Okay, I'm sorry, base 10. So 11 in base 10 we got. Okay, if you add all these things. Okay, so how do we get this octal number now? Octal number is 11. We have to do it with 8. So 8 ones are 8. So what is the value that will be remained? 3, right? 3, I think so. So 8 ones, 8, yeah, 3. Next, 8 zeros are 0. We'll have 1. So from left bottom to top, we have to use. Therefore, 11 of octal 10 is equal to, what is the value? 13 of octal 8. That's what we have to write. So what is the value that I can write it here now? Please remember, is it 13? I don't have any choice to place to other side. So this is what octal 8 this is. Please remember this point. Okay. So this is the total result. In this one, the sum value is 316, carry is the 1. Otherwise, if you ask what is the result of this addition operation, means 1316 in radix 8. Similar thing that you have to remember for any number system. So, okay, for the sake of simplicity, I'll go for hexadecimal also, because these are all the very important, right? So we'll go for hexadecimal. Example number 3, hexadecimal number system. Now, what we do is here is that, for example, 7BA 2CB. Something like this I have written. Something I have written. So what is the value of this one now? Can anybody guess what is this value? I want to perform the addition. This is the 16 radix. This is the 16 radix. Okay. Guess what is the value? A means what? 10. B means 11. If you add these two things, 1, 2, 21. Is this 21 is a valid digit in 16 digit? To 16 radix 16? Not possible. So what I have to do is that this 21 I have to do it, converted it into 16. Okay. What is this value? 16. So what is the value here? 5 will be the answer. Next, we have to perform 16 with 0. Will we have 1? So this is how we need to write. So 21 of 16 is equal to 1/5 of radix, sorry, what I'm sorry, this is a 8, 10, this is the 10 is equal to radix 16. So what I can write here is that 15, it is possible to write 15. 15 is, it is possible to write F, right? It is possible to write F. So therefore what I can write here now? I can write F here. Agreed? Now what about the B and C? I want to add B, C. What is the B value? This is required A value. This is required B value. So now B is equal to 11. C is equal to 12. So what is this value? 23. So that means 23 of base 10, I want to convert it into something into 16. How do we do this one? So very simple. 16, we have to perform with 16. So 16 twos are 32. So it's not possible, only one time. Therefore, it is, what is the value? 16, 4 plus 5. 5 will be the answer here. And the next, this is 16, 0. Is it 5? What is the value? Is it right? I'm doing, please help me here. I think 7, this is, right? 16. So 23 plus 16 both and Babu. 13, 13. Yeah, it's 7. It is 7, not 5. 7 is remainder. And this is 0. Sorry, this is the 1, right? This is the 1. So we have to do it here. Therefore, 23 of base 10 is converted into 17 in base number 16. So how do we do this one? Base number 17. That means that 17 will be the number that we have. So what we have to do is here is now here 7, we have to keep it here as a sum signal, and this is a carry signal. This is a sum signal, this is a carry signal. So carry we have to move to the forward like this, and we have to add 7 to 10. 10 means here. That's it. So it is in radix number 16. I hope you can understand what I'm doing here. So whatever the number system it is, if you want to perform the addition operation, first we have to add the digits. If it is a valid digit, then we can keep it there. If it is not a valid digit, keep one digit, and another digit we have to move it to forward. That's what we have done. Okay, so this is the addition operation. So in fact, any number system can be possible to do this in this way. Another one is, very important one is, so this so far we have seen that addition operation, right? So I'll keep it heading here is addition. Okay. Now let us consider subtraction. Of course, let us do one thing also. For example, another number system also will do it. So for example, binary number. For example, 1, 1, 0, 1, 0, 1, 0, 1. What will be happen? So please remember that if 0 is added with 0, normally we'll have a 0. If 0 is added with 1, we'll have 1. If 1 is added with 0, here also the 1 only the output. But if it is 1 and 1, if you add, what is the result here? Normally 2 will be the base 10 will have that one. But 2 is not a valid digit. Therefore, we have to convert this one. What is the value of this one? 2, if you want to do it 2, 2 ones are 2, that is 0. Therefore, 2 zeros are 0, it becomes 1. So what is this result? It is 1, 0. It is the result is 1, 0, not 2. So therefore, if you add 1 plus 1, 1 plus 1, if you add, what is the result here now? Please remember that it is 1, 0. Here the 0 is the sum, 1 is the carry. Okay, so the same thing of operation basics. This is the basic addition operation in binary. In binary, right? So therefore the binary arithmetics, how do we do this one now? Binary arithmetic. So 1 plus 1, what is happening here? 1, 0. Put it 0 here, and 1 must be carried forward to this way. If you add this 1 plus 0 plus 0, it will be the 1 only. right? 1 plus 1, 0, and 1 will be here in this way. So therefore 1 plus 1, 1. So if these two things are there, 0 will be the sum, carry will be the 1. Put it aside. Therefore 0 plus 0, 0, carry will be the 1 is available already. So this is how we have to do it. This is what the result of this one. So out of this one, out of this one, 1 will be this one. We can call it as, so this one we can call it as carry. This one we can call it as sum. That's what we have to do the addition operation. So let us go for subtraction. So here the care is required. Okay. So far we have seen that, for example, 7, 3, 2, 1, 0, 5, 4, 3, 2, 1. For example, something like this I have done. I want to perform the subtraction here. I want to perform the subtraction on a decimal number system. It is a decimal number system. So if I'm writing the subscript for this one is 10 means it's a decimal number system. What I can do here is that we know the concept called borrow. So we know the concept called borrow, and we know the difference. So whenever you perform addition, there will be a possibility of the sum signal. There is a possibility of the carry signal. Similarly, if you perform the subtraction operation, there is a possibility of the borrow signal, and there is a possibility of difference signal. So difference means this is the lowest position, right? So this is the lowest position. From lowest position to lowest position of the negative number, we have to perform this one. So is it possible to 0 is subtracted from 1? Not possible. We have to borrow something from the succeeding number. So we take some borrow here. So then it becomes 10. Okay, 10 lo nunchi 1 పోతే ఎంత అవుతుంది 9 is the answer here. So here 0 is there. 0 minus 2, is it possible? No, we have to take another number from here. So what it becomes? This is again 0, 10 lo nunchi 2 పోతే ఎంత 8. Here is the 1 is there. Is it possible to 1 lo nunchi 3 పోతుందా? పోదు. Therefore we have to take another 10 from there. So what is happening here? It's 11. So 11 3 పోతే ఎంత అవుతుంది మనకి? 11 లో నుంచి 3 పోతే okay 8. So here is the 2 is there. 2 is 4. Is it possible to subtract from 4? 4 from 2? No possible. So we take another 10 here. So it becomes 12. 12 లో 4 పోతే ఎంత? 8. So what is there here in the 7? 6 is only available because 1 is given to this one. Therefore 6 minus 1 will be the answer. So this is what we have to perform. Okay. So there is no, so therefore borrow is available here. We take the borrow from the, this is the way, something like this, but there is a possibility of the borrow is possibility here also. Okay, there is no issues at all. Okay, so with nothing is available here. So it is how we will write the base 10 value. For example, 5, 4, 3, 2, 1, 7, 3, 2, 1, 0 is the, what is the value that we'll get? So smaller to larger that I want to perform. Smaller to larger I want to perform. Then what we have to do? So general practice, what we do is that it's very difficult to perform this operation. So what my conclusion is that difficult to perform directly. Okay. So indirectly what we do is that we take 7, 3, 2, 1, 0. So indirect method, 2, 1, 0. So I keep it is 5, 4, 3, 2, 1. We'll do this one. So this value is equal to 1, 8, 8, 8, 9. And I keep it negative sign for this one, right? This is what we do. Is it clear to all of you? This is what actually we do in our regular day-to-day life mathematics on subtraction. right? This is what the problem is actually. Similarly, the same kind of problem is applicable to the decimal numbers, the octal number system, hexadecimal number system, binary number system also. Okay, so therefore, there should be some kind of mechanism is required to represent the negative numbers, so that only the addition is possible for us. So I don't want to go for the subtraction directly, something like that. Okay, that means instead of performing the subtraction operation, I do the addition only. I don't want to perform the subtraction directly. How do we do this one? Are you getting? So instead of A minus B, if I want to do it something like this, instead of doing directly A minus B, what I'm going to do is that A plus minus of B, I want to write it. This is what I want to do here. So that means, suppose this is a 1x, for example, this is x, we can call it as plus, it is y, we can call it as, right? So therefore, that means that for positive number, I don't have any problem. If I have a negative number, I want to do some kind of different methodology. That means I want to represent negative numbers by some means. Right? So for that is called, so there are the different ways that we can represent negative numbers. Okay, so therefore what I can do here is that, so in order to perform subtraction, we use addition instead of that. We use addition only. For that, we should represent negative number by different approach, different methodology, different method. Okay, what is the different method we will write now? Is it clear to all of you? Okay, so therefore this is called, this we can call it as, this is can be the negative numbers. So the representation of the negative numbers uses a different method. I told you that is called sign magnitude representation or complementation. Okay, so what I can write it here is that to represent negative numbers. So minus VE stands for negative numbers, I usually write. So you please understand that one. To represent the negative numbers, two approaches. Two approaches are there. Okay, number one. What is the number one? It is called sign magnitude representation. The next one is called complementation. Is it clear to all of you why we have gone for this kind of approach? So because negative number manipulation of the things with the negative numbers is very, very difficult. Okay, so therefore it, in fact, when we want to realize this digital system in order to perform a subtraction operation, it's very difficult. The efficiency of direct subtraction is very difficult than that of representing a negative numbers in this fashion and do the addition operation. Is it clear to all of you? So the thing is that in order to perform an addition operation, we want to design one digital system. That digital system cannot perform, okay, that digital system cannot give you an efficient result, okay, if you are using the direct subtraction like shown. Whereas if you represent the negative number with the positive, represent the negative number in a sign magnitude representation or complementation, then design the digital system, it performs very well. The efficiency of the digital system is very good when you represent a negative numbers by using the sign magnitude representation or complementation method. Complementation representation. Okay, we can call it as complement representation or something else, we can write it there. Okay, so let us write now what do we mean by sign magnitude representation. How do we represent a negative number in that sense? Okay, so we put on this heading is sign magnitude representation. Okay, what we do in this one. So in this particular approach, what we do is that, so we have to represent, for example, 23 is there, plus 23, for example. So that means it's a positive number. The plus sign was, we know very well about it. Plus symbol stands that it's a positive number. Minus 23, if I'm right like this, it is a negative number. Okay, whenever you do something like this, we have to represent with the binary number system. Okay, in that binary number system, whatever the MSB position is there, that will decide whether it is a positive number or negative number. Okay, so what does it mean? What is the digital, what is the binary representation of 23? As we know that, manaki ee code manaku telusundali 1, 2, 4, 8, 16, something like this. The code we should know. So what is the binary representation for 23? Everybody knows that. Ent undali 23. 16 plus 8, what is the value? 16 plus 4 plus 2 plus 1. It will be possible. Ikkada 1 undi, ikkada 1 undi, ikkada kuda 1 undi, ikkada 1 unte 23 vastunda. It must be,
sir.
Yeah. So it must be 0. Must be 0. That's it. That's 23. Okay. So whenever you are representing this 23, this number is called a magnitude number. What we can call it as magnitude. It is called magnitude. And we have to keep, if it is a positive number, we have to keep additional bit that is called 0 bit. If you want to say that it's a positive number. So by looking at extra MSB bit, something like this, we can say that it's a magnitude sign representation. This is called sign. By looking at 1, we observe that it's a positive number. If it is a negative number, for example, what we have to do? So we have to keep this as 1. We have to keep this as 1. It is MSB position. And remaining all are remaining magnitude that we can write it 1, 0, 1, 1, 1. Okay, all these things we can call it as magnitude. Right? So therefore, whatever the number that they give, identify that MSB bit position is meant for sign representation, and remaining bits are represented for magnitude, or it can call it as value. Is it clear to all of you? I will give you one number that you can understand, or you can tell me what is that value is all about. Okay. For example, something like this. For example, I will give. For example, what I can give, suppose 0. So for example, something like this, 0, 1, 1, 0, 1. I have given something like this. It's a base number system too. I want to represent it in sign magnitude representation. This is a binary number I have given, as you know that. What is its equivalent to sign magnitude representation of this number? Whether it is a positive number, it is a negative number. So whatever the size of the bit positions, whatever the size of the bits I have given, it doesn't matter. Please identify that. So the MSB is
Negative number, sir.
Yeah. No, please understand. And remaining positions are magnitude. So by looking at this MSB bit position, it is 0. As what we have seen that
Positive number.
yeah, MSB is equal to 0, then it is called positive number. Then it is called positive number. If MSB ganaka 0 unte, sorry 1 unte, then we can call it as a negative number. Okay, that's what we have to remember.
Plus 13, sir.
Exactly. It is plus 13. So this is plus 13. So just we have to remember the magnitude value. How do we get the value? 1, 2, 4, 8. So where 1 is available, 8 దగ్గర ఉంది, 4 దగ్గర ఉంది, and then 1 దగ్గర ఉంది. Therefore 8 plus 4, 12, 12 plus 1, 13. 13 is the answer. For example, something like this I give 0, 1, 0, 1, 1, 1. So what is the sign magnitude representation of this number? Again, we understand that this is a magnitude, which means that plus. What is value remaining? 8, 4, sorry, 1,
6,
4,
16.
8, 16, right? 16. 7 plus 16.
23, sir.
23.
Yeah, exactly. It is 23. Exactly. For example, write another one. So 1, 1, 0, 1, 0, 1, 0. So what is the sign magnitude representation of this?
Minus.
Yeah, exactly. So what we have to do? MSB, whatever the size, it doesn't matter. If the MSB is this one, you keep it negative. And what is this value? 1, 2, 4, 8, 16, 32. So 32 plus 1. So 32 plus 8, right?
42, sir.
42.
So 42. So 42. That's it. Vice versa, if I ask, so what is this value then? What you can say?
110.
110, 1010.
Do one thing. So first of all, you should know the size of this one for the 42 magnitude. What is the minimum number of bits are required that we have to know? Okay. So what is the 42 here? 42, I want to do it here. So if you do something like this, it will take a lot of time, right? So am I right or not? So if you do something like this, it will take time taking. So instead, what I have to do is that weight positions I can use instead. 1, 2, 4, 8, 16, 32. So up to 32 is possible. Okay. So 32 plus how much value that I can add 42 will come?
8.
32 is required, right? Anyway, 32 is required. Yes. Next. 8 is required. Yeah. 8 is required. 1 is required. Something like this. Okay. So 40, 42. So remaining all are zeros only. This is how we have to do the first of all. Okay, then since you want a negative representation of sign magnitude number, then we put 1 at an additional bit we have to use. Is it clear to all of you? Is it for sign?
Yes, sir.
Yeah, that's it. So if any number, if I give, it is possible to write it both sides. Okay, similarly, can you do it here again? What is value? 23 means 16, up to 16 is sufficient, right?
Yes, sir. Sufficient, sir.
16 is sufficient. 16, 8, 4, 2, 1. So how do I write now? 23 and try to
16, 4, 2, 1.
16, 4, 2, 1. Okay, 23. So I put remaining is 0. Okay. Now, if you want to represent this one as a sign magnitude representation, I put it here is additional 0. So this additional 0 is meant for sign. Is it clear to all of you? Okay, fine.
Sir,
Yeah.
if generally given 1010, how can we identify that is a sign or it's a number?
They will tell you that. Okay, so they will tell you that it's a sign representation. We have used the sign representation. Okay, so they will mention that. Suppose if I say that the 101, if it's something like this, it is a signed or unsigned. How can I know that? Unless otherwise I tell you to tell you this one. We should know that it is a signed number, it's an unsigned number. It is an unsigned number. If it is, then what we have to say that is simply, what is this value? 1, 2, 4, that is 5. Unsigned 5 value, that is actually. For example, it is a signed unerror. For example, it is a signed unerror. Then what we have to think about it? So you don't want to consider this one. Only magnitude is 0, 1 only. Okay. Okay, then what is this value? Minus 1. That's it. They will mention that whether it is a signed signal or unsigned signal, right? Unsigned data or signed data. Fine, good. Now the question is that I have, for example, I'm using the 4 digits, 4 bits, for example. I'm using the 4 bits. Then in sign magnitude number, the question is you have to understand. I'm asking one question. If it is a 4 bits I'm using, how many number of sign magnitude digits can be possible to represent? How many number of possible digits to represent? See here, 4 bits use chestunnaru. Okay na? So 0 can I represent 0? Yes. What is the value of this one is 0 0 0 0. Ante kada. So therefore MSB last bit is meant for sign. Okay, plus. Okay. Next. 1, am I able to do it? Yes, of course we can do it. So here what is happening here? 0 0 0 1. What is this MSB? It stands for positive 1. Like this, how many I can do it here? Anyone? Anyone? Is it possible to do it for the 2? Is it possible for the 3? Is it possible 4, 5, 6, 7, 8, 9, 10? Is it possible?
Yes, sir.
Up to what number? Is it 5, 6, 7, 8, 9, 10?
Up
Yes,
to
sir.
7, sir.
Yeah, exactly. 0 0 1 0 zeros, because only the MSB bit is we have to leave it. There is no doubt at all. It represents only the sign. Okay, that means that the plus value, so it is representing plus 1 plus 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 plus, right? Plus something like that. So therefore 0 0 1 1 0 1 0 0 0 1 0 1. 6 means 0 1 1 0. 7 means 0 1 1 1. So that's it. We are able to do it on the right hand side. 8 cannot be represented. Okay, please remember that 8 cannot be represented. If you want to have 8, what we have to do is that 4 bits are not sufficient. Agreed? 4 bits are not at all sufficient. Sorry. Fine. So therefore the right hand side, this is only possibility. For example, the negative side, how many number of digits? Not possible. Okay, for 4 bits, it is not possible. Not possible with 4 bits. So it is not possible to represent 8, 9, 10, so on up to so forth. Then not possible with 4 bits. And we are not able to represent, what we can say that it is not possible to represent with 4 digits for the 9, 8, 10, so on up to so forth to infinity. Okay, so therefore this is only the maximum limit is available here only. So this is the sign representation, sine, 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 sine. Okay, so we have only the possibilities maximum this value. Okay, now left hand side, what is the value that we are able to do it? So it is also possible. Negative number means 1 is also possible, right? 1 0 0 0. Next, minus 1 is there, minus 2 is there, minus 3, minus 4. How many? Yes.
Up to -7, sir.
Up to 7.
Yeah, up to 7 only, -7 only. So here also, what we write here is that, I think better this color I want to use it. 0 0 0, 1 0 0 1, 1 0 1 0, 1 0 1 1, 1 0 sorry 1 0 0, 1 1 0 1, 1 1 1 0, 1 1 1 1. Ante add మనం చేయగలం. So this is up to this point only, because MSB bit is meant for sign representation. So therefore, what is the maximum values that I'm able to do it here now? So therefore, in the sign representation, so if we use 4 bits for sign representation, sign magnitude representation. So what is the allowed range here? -7 to +7 only. So let me write for generalized thing, for generalized case. What we can write for generalized case? For n bit, for example, n bit. So for the n bit, what is its range? Can anyone guess? For n bit range, I want to write it for anyone from the class. So it's very simple. So how do we represent the 7? How do you represent the 7? Is it, shall we write like this? It's a binary number system we are using. Base n, power n, minus 1. Is it clear? 2 power n and 10,000 babu 4 bits and
Yes, sir. It's correct, sir.
4 minus 1, that is equal to 8 minus 1, that is 7 can be
7.
represented. Okay. The right hand side, so this I have defined. Whatever minus 7, same only, minus of 2 power n minus 1 to this one. The range. Therefore, minus 7 to.
Sir, 2 power 4, 16, sir.
Yeah, exactly. 2 power 4 is 16. So I'm sorry. Exactly. So what is the value then?
2 power n minus 1.
Exactly. 2 power. Thank you very much. 2 power n minus 1. It's not n minus 1. It is n minus 1. Therefore, what is happening here? Minus 1. That is now, it is 8. This is 7. Excellent. Thank you very much. So like this, for example, if I ask you the question, one question I'm asking, if I'm using the 7 bits for a particular number in a sign magnitude, what is the number range? Where from it start from, where it stop? 7 bit I'm using in sign magnitude representation, then how many numbers can be generated? So here I'm saying that numbers are generated from minus 7, minus 6, minus 5, so on up to plus 7. Okay, that means total of what is the value of this one? And then I have 14.
15.
So 15, 7,
0,
7.
sir.
0 is also there, right? Yeah, 15 possibilities there. Like this, what is the value? Just we have to use this formula only. 2 power 7 minus 1 minus 1, 2. 2 power 7 minus 1 minus 1. What is this value? It's 2
63,
power
sir.
6 minus 1, 2. 2 power 6 minus 1. 2 power 6 and anta there.
64, sir.
64.
Yes, minus 63 to plus 63, right? So these many numbers can be generated if you're using the sign magnitude with 7 bits. Agreed? So there is okay, time is up. Can you wait for 1 minute, 2 minutes? I will complete this topic, just 2 minutes. Okay. So what is the problem with this one is, you please identify that. So whenever you are using the same representation, so that different representation for the same number, it's very difficult to perform the arithmetic operations. It's very difficult to perform the arithmetic operations. So for the one, we are using this one. For the minus 1, we are using the different number. What is happening here? Let us consider this problem. What is the problem with this sign magnitude? So problem in sign magnitude. What we do is that, so for example, minus 5 is there, plus 5 is there. I want to perform addition. So generally what we have to do is that when manually we do the addition, what is happening here? 0 will be the answer, right? Agreed? Okay. For example, if you want to use the sign magnitude representation methodology, if you use sign magnitude, if we use sign magnitude, then what will happen? See, minus 5, how do we represent? 101, but we have to keep it 0 at the MSB position. Plus 1 stands for, again, sorry, I'm extremely sorry.
But for minus, we should use 1.
1, yeah, exactly. 1. So for 0, plus 5 stands for 0, 1, 0, 1. 1, 0, 1. So this is actually the minus 5 representing, this is plus 5 representing. So what is value? 0, 1, 1, 0, 1, 0, 1, right? Is it right answer? Is it equal to 0? No. So therefore, this is the problem with the sign magnitude representation. Therefore, other methods are, other ways are there to correct this one. But at the first instant of the time that we understand that whenever we give the same different numbers for the same number, so different representation for the same number, okay, different representation, this is one representation, this is another representation for the same number, then it is very difficult to identify, it is very difficult to provide the correct results. Right? This is the problem with the sign magnitude representation. So therefore, we have to go for another method by which the same representation used for for the same number. Okay, so that we will look at in the next class. Okay, preferably, actually, there is a problem with this one. So preferably, actually, this 0 has got different meanings. Okay, so how do we rectify this problem by using the complementations? We will see in the next class. We stop here today, and if you have any doubt, please let me know through the modules only. Okay, or otherwise you can use the WhatsApp link also. So everyone, my sincere request is, students, my sincere request is